Last time that I talked about improper integrals, I said we can use inequalities to help us know when more complicated improper integrals exist. So I said, I've got functions f of x and g of x. F of x is always greater than or equal to g of x, and both of these functions produce positive values as long as x is big enough, right? I just said across the whole number line, we can do that in just a certain range. I talked about if the improper integral of the larger function converges, then the integral from a to infinity of the smaller function will also converge. That makes sense, right? Because integrals are measuring area. If this integral is representing a finite amount of area, then this integral also has to represent a finite amount of area. But this test can cut the other way too. We can say that, well, g of x is always smaller than f of x. So the integral of f has to be bigger than the integral of g. Well, that means if the integral of g of x from a to infinity diverges, if that's an infinite amount of area, well, then f of x has to be bigger than that for all coordinates x. That means the integral of f of x has to be greater than the integral of g of x. So if the integral of the smaller function doesn't exist for improper integrals in this way, then the integral of the larger function also won't exist.